Let x be the z value. So that you will, I made this assumption so that you will not be confused what is x about. So you have p of a z score greater than 0 but less than x. So where after of a z score that is between 0 and, I mean, the probability distribution of the z-score from 0 to x, where x and 0 here are both specific score or specific z-value, is 0.4678. So we are going to find now x, this value. What is the x here, which is from 0 to x? This is the probability distribution. So it's like in the diagram, if this is a 0, this is the x, and then this region is 0.4678. That's the region. So we're concerned now is what is the x? Okay? How to find the value of x? To do that, that's the time we're going to look at the table. From the table, you will look for this value. So the probability distribution of 4678, 46. Okay, in this case, there is exactly there is an exact value of 4678. This one, this point up until here, the x value here is equivalent to 0 point, or not 0, but rather 1.85. Okay, so meaning to say, the probability distribution of 0 to x is 0.4678, then that is exactly referring to a z-score that is from 0 up until 1.85 using the table. Now let's try to find what about this the given. What is the probability distribution of a z-score greater than 20%? Okay? What is the z-score of a distribution that is greater than 20%? Take note, this is 100%. So in a diagram form, we're going to have it this way. Okay, 0. Let's say this is the 20%. This area here is 20%. Since greater than 20%, we're exactly referring to this area because that's exactly greater than 20%. So technically, we're talking about the 80%. Take note, this side here is 50%, while the other half here is 30. Because 30 plus 20, that gives us 50. 50, 50, that's 100%. Now, let's find what is the z-score. What is this value? What is the z-score in this area? To do that, since we know that this is 50, so the remaining half is 30. We're going to find now what is the p of a z-score greater than x but less than 0. So exactly referring to this area. Because equals 0.3 or 30%. Because 30%, that's the half. Since we have here the 30, we will get this value. And then once we have that value there, once we have this value, we can identify already what's the z-score here. So what is the z-score? What is the x? Okay, find the z value. Okay, find the z value of z value for a probability distribution greater than 20. Okay? So find the z value for a probability distribution greater than 20%. So the 20% is here. Greater than 20% is going this side. We know that that's 50, so we're just trying to get the z value. This point here is from 0 up until this point. And to do that, we have it in this form. So what must be the x? Such that the area bound by the curve of z-score between x to 0 is 30%. Now, in the table, this is what you're going to see there from the table. You will be torn between two scores or two probability distribution. But I need you to pay attention carefully which one you're going to take. So we will look for 0.3. Okay, these are the two values. You will find there 0.2995, and then the other one is 0.3023. Okay, these are actually the two values here closer to 30% that you are going to look into. Now, this is how we approach it. This is closer to 3, but this is beyond 3, this is not yet 3. Now, what we're going to do, we're going to drop not this one, but rather the one that is closer, that is before. Because basically, this is more than 30%. So what we're going to do, we will take this value, 0.299. That's always the case whenever we will be provided with percentage. Now, we will look for the z-score equivalent to this one. The z-score equivalent to 0.2995 is 0.84. So this is equivalent to our x here is 0.84. Thus, the z value here, this is negative 0.84. Take note negative because it's found below the mean. So later on, whatever is the, you can convert this into actual score, whatever is the data. And now let's take an actual example. Okay, let's take some example here. Please bear with me. I'm not gonna write the whole problem because it's quite long and I only have a very minimal space. I'll just read the problem instead. Here's the problem. The average pag-ibig salary loan for RFS Pharmacy Incorporated employees is 23,000 pesos. So the average loan of these employees, of the employees of the pharmacy is 23,000 pesos. That's the average loan of their employees in pag-ibig. And then with a standard deviation of 2,500. Okay, that's the average. That's the standard deviation. Now, the question asked here, find the probability that the employee owes less than 18,500. If the average debt of the RFS pharmacy employees is 23,000 pesos with a standard deviation of 2,500, what is the chance of an employee having a loan of less than 18,500? So that's the question. Now, here is what we're going to do. First, we will look for the value, the z value equivalent to equivalent to 18,500. So first step, okay, you don't need actually to show this one, but I'm just going to write here the steps so that everybody will be able to follow as to where we started and where we will end. First step is we will solve for z equivalent to 18,500. So that is z 18,500 minus 23,000 divided by 2,500. That is how we will find our z. 18,500 minus 23,000 divided by 2,500. So that's negative 1.8. So the z value equivalent to 18,500 in relation to this mean and standard deviation is negative 1.18. Thus, 18,500 deviates away from 23,000 pesos of equivalent to 1.81 standard deviations below the mean. Okay? So to illustrate that one in a diagram, the zero here means 23,000. Okay, I'll just put it here. That's 23,000. And then this score, this z value is negative 1.8. This is equivalent to 18,500. But the question is what's the probability that the employee owes less than 18,000? Meaning to say less than, smaller than this amount. So where should I go? I should go there or here. We are referring to the region bound by the curve and on this area. Okay, this is exactly the less than 80,500. So the chance that an employee is, the deaths of the employee is less than 18,000, they are found in this area. So the employees found in this area, all of them are actually, their death is less than 18,500. So the question now is, how do we find this? Let's describe this probability here. That is P of a z-score that is less than negative 1.8. That's our problem. But to solve for this one, we know for a fact that from the table, the z table, it's only from 0 up until this one. So we need to get this proportion. Okay, we need to get the value for this area, so which is, this is P of a z-score greater than negative 1.8 but less than 0. This one. This area. Okay, where the arrow from. So which is the value from the table, that is, what is that? 1.8, 4641, which is 0.4641. Now, we will, to solve for this area, this one here, this is simply 0.5 minus this portion, the non-shaded portion of the half, the lower half. So that is minus the P of a z-score negative 1 greater than negative 1.18 but less than 0. So you have 0.5 minus 0.4641, our answer, minus 0.4641, that is 0.39. 0.59, 0.0359, or 3.59%. Therefore, to answer the question, therefore, the probability that the employee owes less than 18,500 is 3.59%. Okay? That is at least how we complete the solution. So the question for us here, find the probability that the employee owes less than 18,500. With the entire solution here, we conclude that the probability that, or the chance that an employee owes less than 18,500 is only 3.59%. Is that clear?
Yes, sir.
Were you able to follow the entire solution?
Yes, sir.
Is there, do you have any question?
None so far, sir.
Okay, let's take this another example. I will not write the problem, but I will read the problem and I'll give you like 5 minutes more or so to solve on your end. And then I'm going to ask somebody to give us the answer. The question here is, or the situation goes like this. The average age of bank managers is 40 years old. Okay, kindly take down the details or the given. The average age of the managers is 40 years. 40 years. Assume that the variable is normally distributed. If the standard deviation is 5 years, find the probability that the age of a randomly selected bank manager will be in the range between 35 to 46 years old. Okay, that's the question. Did you understand the question? Again, the average age of a bank manager is 40 years. Assume that the variable is normally distributed. If the standard deviation is 5 years, find the probability that the age of a randomly selected manager will be in the range between 35 to 46 years old. So what is the chance that the age of a randomly selected manager, his age is between 35 years old to 46 years old? Okay, I'll give you 5 minutes to solve that, and then later I'll call somebody to give us his or her answer. Go ahead. I hope you are solving. Okay, let's write down here. Our The mean age is 40. The standard deviation is 5 years. Okay? The question is, what is randomly selected? Okay, there you go. The mean age of the bank managers is 40 years old with standard deviation of 5 years old. What is the probability that a randomly selected manager will be in the range of between 35 to 46 years old? Okay, first is we will convert our two ages here to z value so that we will know what we're looking for. Let's start with z equals 35 minus 40 divided by 5. That is negative 1. And then another one, z equals 46 divided by 4 minus 40 divided by 5. Okay, you have 1.2. So we have now the 2z score. Drawing or having out the graph, this is 40 years old. One score here is negative 1 standard deviation below the mean, and then the other age is 1.2 standard deviation above the mean. Since the score is, or the question is between these ages, so that is referring to this area. We all know that from the table, we just know this part and this part. So this area is the probability distribution of a z-score, negative 1, greater than negative 1, but less than 0. This area. Which this area also is a probability distribution of a z-score greater than 0, but less than 1.2. Now, looking at the table, this value here, that's 34, 0.3413. Okay? And then, well, this one, 1.2 is 3849, 0.3849. Okay, so we have already this value. Then the next thing that we will do is we will combine this together, this area. Okay, we will combine that area, okay, the entire shaded region to be the probability distribution of a z-score greater than negative 1, but less than 1.21. That's the probability or the chance that our randomly selected manager ages between 35 to 46. So that's our problem. That's the P of a z-score greater than negative 1, but less than 1.21. To solve this problem, we'll just simply combine the probability of a z-score. I think I just need more space. Z greater than negative 1, but less than 1.21 is equal to the probability distribution of a z-score, negative 1, but less than 0, plus the probability distribution of a z-score greater than 0, but less than 1.2. Combined now, this probability here is 0.3413, plus the other one is 0.3849. Combine that, you have 0.7262. or simply 72.62%. Therefore, to answer the question, thus the probability that the ages between 35 to 46 years old is 72.62%. So the chance that the randomly selected manager will have an age of, between 35 to 46 years old is 72.62%. Anyway, let's have this another problem. This problem is having another situation. This is using already approximate values for our z value. I'll just read to you the problem. Here's the situation. To qualify for a master's degree program in business administration at Sebastian College, candidates must score in the top 20% of the mental ability tests. The test has a mean of 180 and a standard deviation of 25. Find the lowest possible score to qualify. Assume that the test score is normally distributed. Now you notice that in every problem we're dealing, it was verbatimly mentioned that the data is normally, or the variable is normally distributed, because z-score is only applicable for normal distribution. Okay, that's why it is normally, or you will always find the word normally distributed in all of our questions. So again, I'll just try to emphasize the question here. To qualify for a master's degree program in business administration at San Sebastian College, the candidate must score in the top 20. Must score in the top 20% on a mental ability test. So candidate must take out mental ability tests. And then the qualification there for you to qualify for the program, you should be on the top 20% of the takers when it comes to mental ability test. If that mental ability test has a standard, mean of 180, I assume this is points, and then a standard deviation of 25. The question is, what is the probability, or what is the lowest score to qualify? Now let's analyze the problem. It says that you must score in the top 20. So in a diagram, example, this is our diagram. This is the mean, which is 180. You must score in the top 20. So the top 20 is somewhere here, right? Or that is 0.2, that area. So you must be in here such that you will qualify. The question is, what is this value? Okay? What is the z in this area? So that if you will find the z value in this area, we can already get the actual score equivalent to the z. So first is, you will have to look at the table. This is a 20%, but the 20%, our table is only referred from here. We're going to take or find this value instead of finding that value, which is this part. The number is 0 up until here is 50%. And then the remaining half, this is 20%, the remaining half, the remaining portion of the half is 30%. This is 30%, correct? So we're going to find now the equivalent, a z-score equivalent to 30%. So we will get the z-score value here. So we will look for the closer to 30. For the closer to 30% or 0.3, we've got two values. The first value is 0.3. We have 0.2995, and then the other one 0.3023. These are at least the two squeezing values. Which of the two are we going to pick since our percentage here is 30%? we will take this portion or this score. And the z-score equivalent to this one is 0.85. Sorry, 84, 84. So the z-score here is 0.84. Okay? Now, since we've got already the z value, let us solve now. Z equals x minus x bar divided by s. Our x is, or rather, our z is 0.84. Positive because it's above the mean. And then x minus our mean is 180 divided by 25. Cross product, that is 0.84 times 25 equals x minus 180. Product here is, this is 21 equals 1x minus 180. Transpose, that's 21 plus 180 equals x plus 180. So you have 201. Okay, that's our answer. Thus, candidate must have at least 201 score in order to qualify. So in order for the candidate to qualify for a master's degree in business administration at Sebastian College, one should have at least 201 score in his or her mental ability test such that he is qualified to enroll the program. I still have two more problems here which have different situation. Here is the question. I'll just read the situation, okay, because I cannot afford to write all the questions here. Okay, there is one more problem here, which is, I think, where we're going to end. The emotional quotient or EQ score of the latest version of Serog EQ test, emotional quotient test, is transformed so as to follow a normal distribution with a mean of 110 and a standard deviation of 15. Okay? So, an emotional quotient test of Serog is EQ test is transformed. So the data was transformed so as to follow a standard deviation, a standard, normal distribution. So the original EQ test score was transformed. Okay, it was transformed. It was transmuted in such a way that it would appear to be a normal distribution. Now, this EQ test has a mean of 110 and with a standard deviation of 15. The question here is find the 36 percentile, 96 percentile of the distribution of emotional quotient. So for this one, if we draw the diagram, it's like this. Since 96 percentile, assuming that this portion up until here is equivalent to 96%. So the question here is what is the value of this point given this information? So we're going to look now the 96%, but of course the table does not provide us 96%. We all know that this is already 50% from this point up until here. We just have to follow or find this one, which this area from this point, from 0 up until the z here, which is unknown, is equivalent to 46%. Now, what is the z value equivalent to 46%? Because the 46.08, that's already more than. We agreed last time that we will get before, the closest that is before. That is 0.4599 equivalent to 1.75 z-score. So this is equivalent to 1.75. We have 300, 136.25. So the question here, find the 96 percentile of the distribution of the AQ. The 96 percentile of the distributions of the AQ is 136.25. Yeah, there you go, 1.75. Now, if that's 1.75, let us locate now the value. So that is basically, you have z-score equals, okay, we'll solve for the mean first. We have x equals z s plus mu or plus x bar. So you have our z is 1.75, our standard deviation is 15, plus our mean of 110. get the result. So how do we interpret this one? Meaning to say, if you happen to score this EQ, you mean to say 96% of the distribution has an EQ result that is lower than yours, which is lower than your percentile score or your score of 136.25. Okay? So if you are the one who scored 136.25, which you are now in the 96 percentile of the distribution, it means to say that 96% of the distribution has a score, lower EQ score than yours if your score is 136.25.